Hi everyone, today we're going to be multiplying and dividing rational expressions. Your essential question for today is when there is a binomial or trinomial expression in the rational expression, how do you simplify completely? Multiplying rational expressions. If the problem contains a monomial, meaning only one term, you're going to multiply together and then simplify. If your rational expression contains a binomial or a trinomial, you are going to factor everything that you can first, and then you're going to simplify. So for our first example, we see that we have each of our rational expressions that actually have a monomial here. So what we're going to do, we're going to go through and, like our directions actually said, our monomial, we're going to multiply together and then we're going to simplify. So let's go back to that. So let's just go ahead and work with our numerators first and just our numerical values. Our 6 times 10 is 60. X squared times an x cubed. Remember, when you're multiplying the same bases, you add the exponents. So 2 plus 3 is 5. And then you have y, 3 plus 4 is 7. And now we're going to work with our denominators. So 2 times 18 is 36. And then we have x squared times nothing, so it's just going to be x squared. And then y squared times y squared, which is y to the 4th power. Okay, and then our directions tell us that we now need to go start through and simplifying. So what number goes into both 60 and 36? Well, we know that 6 goes into 60 10 times. We also know that 6 goes into 36 6 times. So it's actually a bigger number that we can multiply by, which means that these both go into 2. So 6 times 2 is 12, so 12 actually goes into both of those. So I'm actually going to back up and take a even larger GCF out. So 60 divided by 12 is 5. And then we have 36 divided by 12, which is 3. And now remember, using your exponent rules, you subtract the exponents when we are dividing the same bases. So 5 minus 2, I have more on top, so that means that 3 is going to go up there. And then y to the 7th power minus that 4, y to the 4th power, I have also y to the 3rd on my numerator. Okay, so that's just multiplying them. Let's go to our next example. On this one again, we have monomials. So again, we're just going to multiply straight across and then go through and simplify. So 4 times 5 is 20. A squared times a to the 3rd is a to the 5th. B squared times b to the 6th is b to the 8th. And then we have 15 times 12, which is 180. A times a to the 4th is a to the 5th. And then b to the 3rd times b to the 7th is b to the 10th. Okay, so we multiplied our monomials. Now we're just going to go through and simplify. Well, 20 goes into 180 9 times. A to the 5th power divided by a to the 5th power is just going to equal 1. B to the 8th minus 10 would be a negative 2. That just means that we have more on the bottom. So let's go ahead and rewrite this. So I have the 1 from 20 goes into 21 time. That's actually all I have left up here because these 8's cancel out and I actually only have 2 on the bottom here. So I have 1. You have to write that not 1 on the top. I have a 9 on the denominator, and then I have a b squared. So just 1 over b squared. So that's how we work with our monomials. Our next two examples are going to be the binomials and trinomials. So if we go back to see our steps right here, it says if we have binomials and trinomials, we're going to factor everything you can first, and then we get to simplify. So this time we're going to factor first. So let's just take each little section of our fractions separately. So right now, I have my 4x squared minus 4x. I know my GCF is a 4x, so that means I have an x minus 1 left over. Excuse me. And then let's take my other numerator. I see that the coefficient's a 1, so I get to use my parentheses, just like this when we're factoring. What multiplies to a negative 6 but adds to 1? So multiplies to negative 6, we know that 3, let's make our little multiplication sign right here. We know that we have an x, negative 6. So we know it's going to be a 3 and a 2. Which one has to be positive? Well, the higher one does because we have a positive 1 in that center. So 3 times a negative 2 gets us negative 6, but 3 minus a 2 gets us a positive 1. Now let's go work with our denominators. So now we have our denominators here. Take out a GCF, always, always, always. So 2 is my GCF. I'm left with an x squared plus a 2x minus 3. We are still going to have to factor this portion right here, but we'll just keep waiting until we get to that point. So just go through, factor everything once if it can, and then go through and do it a second step. So let's do our denominator here. Our next GCF is a 4x, and so now I have an x plus 2. Okay, so it looks like the only thing I need to actually factor is that portion. So I'm going to go ahead and rewrite everything that I have already factored completely. Times x plus 3, x minus 2, and then now we're going to go ahead and actually write down this denominator because I also did that one already. And then, okay, so now I'm trying to figure out what two numbers when multiplied get you negative 3, and then they also add to a positive 2. So I know it's going to be 3 times 1. The 1 has to be negative, so that when there's 3 times a negative 1, it gets you negative 3, and 3 minus 1 gets you that 2. Okay, so now I have everything factored, so now I get to start going through and just simplifying everything out. So since there's multiplication, you actually get to start canceling out things across from each other as well. So like what I mean by that, x plus 3 is over here. As long as it's on the top and one's on the bottom, we're good to go to cross them out. Same with this. As one's on the top, one's on the bottom, we're good to cross them out. You don't get to cross out the x minus 2 and x plus 2, different signs. We do get to cross out this 4x over here and this 4x over here. So I think we got everything. So we're just going to rewrite this. Go through. The only thing I have on my numerator is that x minus 2. And then the only thing in the denominator I have is my 2x plus 2. So that's my simplified multiplied value there. Okay. Our next example we have is going through, and again we have a binomial and a trinomial, so we have to factor everything first. Start with that numerator. So I'm going to go through and say that I have a GCF of 5v. Careful, this isn't in standard form, so just be careful that I might actually write it in standard form now. So let's do 5v divided by this negative 5v squared first. And it actually has, since we want it in standard form, let's rewrite this in standard form just because it helps you factor correctly. So we see that that's actually the leading coefficient has that negative, so you actually have to take out the negative 5v. So now if I have a negative 5v squared divided by a negative 5v, it's just a v. And then I have 10v divided by a negative 5 would be a negative 2. Okay, this one already is in standard form, so we're just trying to figure out when multiplied together. I'm going to rewrite this over here just because I not think I'll have enough room. So I had a negative 5v, and then I had a v minus 2. Okay, now multiplied, I'm trying to figure out what value when multiplied gets you negative 9, but then adds to a negative 8. So I think negative 9 plus 1. Negative 9 times 1 is negative 9. Negative 9 plus 1 is a negative 8. Perfect. And then now I have a trinomial again, so I'm trying to figure out what values when multiplied get you 18, but then when added get you the negative 11. So if we do 9 times 2, we need a negative 11 and a positive 18, so let's do negative 9 times negative 2. It's a positive 18. Negative 9 minus 2 more is going to get you your negative 11. So check, we got that right. And yay, this 15v we don't get to do anything with. It's already factored for us. So now we've factored everything completely, we get to go through and start canceling things out. So I'm going to start off with this negative 5 first. So negative 5 goes into negative 5 once, but it goes into this 15. And you guys can leave the negative on the top or the bottom. I'm going to say negative 5 divided by 15 is negative 3. Okay, and then these v's also cancel out with it. V minus 2 cancels, v minus 9 cancels, which is nice because we got to cross out this entire value. And then now we just have that v plus 1 on the numerator, and then we have that negative 3. Sometimes you guys might see, you can also write it like this, where you have a negative v minus 1 divided by 3, or all these different ways for math. You have the v out in the front, because then it can get distributed to either denominator or numerator. The next thing we're going to do, we're going to divide rational expressions now. So in order to divide your rational expressions, you're going to multiply by the reciprocal. And then the same rule applies if you have your monomials, you're just going to multiply straight across and then simplify. If you have your binomials or your trinomials, you're going to go through and factor and then simplify. So let's see our first example here. On our very first example, we have our monomials. Awesome. So now we have to multiply by the reciprocal. So you only flip that second fraction. So we have 5pq divided by 16p to the third. Now our sign is going to change to multiplication, and we reciprocate this second fraction there. So now our 8q to the 5 is on top, and our 35p to the second power q squared is now on the bottom. Since we have both monomials here, we can go ahead and actually multiply straight across. There is another little secret, you guys. If you guys simplify before you start multiplying, look at 5 goes into 5 one time, 5 goes into 35 7 times. I have a p here. You can simplify it with the p on the right here, or you could do this one as well. So I'm just going to, since I'm already simplifying diagonally, I'm just going to get rid of that p and get rid of this squared. That means I just have one p. This q is going to give me just a q here. And then this 8 goes into 16 2 times. And then I have a q5 and a p to the third. Okay, so now that I went through and simplified my fraction, I want to actually go through, this little 3 is canceled. If I want to actually go through and multiply straight across now, so the 1 times the 8, that 8's canceled out, I actually just have a q to the 5th on top. And then I have my 2p to the third, and then here, actually let me back up so you guys, it's a little confusing. Let me show you guys what I have left on my fraction. There's nothing left up here, so I just have 1 divided by 2p to the third times q to the 5th divided by pq. So technically I could have divided out one more of those q's, but we could do it now. So now I'm going to multiply straight across. I have q to the 5th on top, and then I have 2p, remember these are all 1 exponents, so I have 2p to the 4th, and then I have a q to the 1st power. So the only thing I get to cancel out, I get to cancel out one of these, making me have no q's on the bottom, and then that makes that a 4. So I'm going to rewrite that. So I have a q to the 4th power. I just think sometimes simplifying in the beginning is actually easier instead of getting large numbers. So I would like to simplify in the beginning. Oh, and I guess I forgot that 7 right there. So bring down that 7. That means that we have 2 times 7, which is 14. I caught my own mistake. And then that makes this a 14 now. So I actually have q to the 4th divided by 14p to the 4th power. That's my final solution. Okay. Now we have a binomial and a trinomial, so now we actually have to factor everything before we can multiply it. So I'm going to write it over here just so I have some more room. That first fraction stays the same, the division sign turns into a multiplication sign, and now we flip these guys. So this x squared plus x minus 6 is on the top, 2x squared plus 6x is on the bottom. Okay, now I get to go through and factor. So I have a 10 here. I know that my GCF on the bottom is a 4, so x minus 2 times. Again, I get to figure out what values multiply to a negative 6, but then add to a positive 1. So I know that it's going to be a 3 and a 2, and it's going to be a positive 3 because I want more positives, and then a negative 2. This one has a GCF on the 2x, and I have an x left over plus 3. Okay, so now I get to go through and start dividing things out. So x plus 3, x plus 3, x minus 2, x minus 2. We know that 10, I'm going to just divide it by this 2 right here so it cancels it out. Okay, so that's all I have left up. I have the 5 on the top. I have a 4x on the bottom. So that's actually it for this one. All right, and our last example here, now we have binomials and trinomials again. It's just kind of getting bigger and a little bit harder. So let's go ahead and rewrite our first fraction because that one is not the one that we flip. And you get a squared minus 4a, and then minus 12 times, and now reciprocate your last fraction there. And then divided by 24a squared minus 8a to the third. Okay, so now go ahead and start taking out GCFs and stuff. So on my numerator I have a 2a squared that I'm going to take out, and I'm left with an a minus a 6. On my denominator I get to figure out what multiplies to negative 12 but then adds to a negative 4. So I know I have an a, and then multiplies to negative 12. So I know I'm going to do 6 and 2. I want a negative, so that means that the higher number is going to be negative. Multiplying. What values multiply to positive 15, but a negative 8. So I have 5 times 3. It multiplies, when you multiply them, it's 15. I have to figure out how to get them to equal a negative 8 though and a positive 15. So that means they both have to be negative, because a negative times a negative is still positive, but then a negative plus a negative gets you that negative 8. Okay, and then my GCF on that denominator between 24 and that negative 8 is actually 8. And I have an a squared I get to take out as well. Then we have 8a goes into this 3 times. And then this wasn't in standard form, so just be careful because remember, a negative, like these two are not the same because we have to actually take out that negative 1. So let's go through and cancel out. Actually, I am going to take out a negative 1 right now anyways, so I can make this look like it. So if I put a negative in front of here, then that means that this turns into a negative and that turns into a positive. So it just switched answers. Signs. So now I have positive a, negative 3. So now we're good to actually cancel these ones out. And then I have an a minus 6, canceled those out. My a squareds here cancel out. The 2 cancels out, making this a negative 4. And then it looks like that's all I can simplify. So I have an a plus 5 on my numerator, and then I have on my denominator, I have an a plus 2. And I'm actually going to rewrite that 4. Let's put this on that negative 4 in front and then do a plus 2. Just a little bit better notation. Okay, and again, that negative can be on the numerator or the denominator, but that's it.